Welcome to video 1, OTDR for Electronics 388. This is made possible by an expert videographer, Andre, and Stan is on the lighting. And I'm just pointing at this thing. So what we have here is an antique Anritsu OTDR, Anritsu Wiltron, and it's basically a laboratory unit. It can be used in a studio or it can be used in a central office, and it's made for long haul looking at fiber optic cable. So what we have is we have it set up right now. Normally we have a test box, but we have to fix the test box, which has a lot of problems in it, and we can look at the individual events. But what I did is I put a reel of fiber down here and plugged it in instead. So it's a perfect reel of fiber. I don't know how long it is, but I can tell with this. And I have the far end unterminated, and we can see a spike. So what I have is I have a marker on here, and we're going to go through and I'll show you how to set it up here in a minute. But real quick, I have a marker that I'm running across here, and it tells me my distance. So I'm going to run it to the end, and that's where the end of the fiber would be, where this thing first starts to go up. And I can see that it's 22.9857 kilometers away. Now I can zoom in a little bit and get a little bit more accurate. And I can see by zooming in, I can put this right on the cusp. Now this makes a difference if I was digging and finding the end of it. So this tells me my exact end of my fiber. So I can see that it's 23.0375 kilometers away. So how did we get this far, and how did we figure out how to do this? I'm going to go ahead and turn it off and start at the beginning and let you see how to do the settings. Okay? The first thing you're going to do is turn it on. It goes through a test setup on the CRT. It tells you what it's doing. It goes through a series of tests and then comes up. The first thing is you got to look at is you got a header here, and what the header has is all the settings: dB per graticule, distance per graticule, all of the information, attenuation settings, horizontal, vertical, the power, all of that. Down here on the bottom I have splice loss set up, so it'll show me if I have the laser turned on, the losses of splices, the distance, and everything down here on the bottom. On the right hand side I have my setup, and this is my soft buttons that control everything. So the first thing I do is I push the condition button, and it tells me distance, pulse, attenuation, and masking, and output power. So the first, I know that I have a roll of cable down there that I'm going to probably set at, I'm not sure what it is, so I'm going to say 50 kilometers. Okay? I know that I have a pulse here, and my pulse should be very, very short. I'm going to choose the shortest one, which is 20 nanoseconds. We go 100, 500, and 1 microsecond. Since it's so short a distance, I just push that, the shortest one. Then I come down and I look at the output power. The output power I set, and it's displayed right there, to 0. It's the lowest there is. It goes way up in power, but since we're going only a short distance, we'll leave it at 0. Attempted there. I hit the set button. I have it in the splice loss. Auto is off. Wavelength select comes down here. I can select either 1550 or 1310. It's set at 1310 right now. And I got the tracer just sitting there, and I'm ready to turn on the laser. The average is off, so I'm in real time. The laser came on. Now, what this knob does is it allows me to move the cursor back and forth and be able to see that if there's any problems with the fiber, and again, bring it up to the end and see that it's about 22.9. My buttons over here, my input, horizontal in and out, vertical in and out, allow me to get closer resolution. or go back to what it was before. I also can vertically zoom in and out by pushing those buttons. And that gives me more gain to be able to see more detail. The reason I don't use the average is it takes a long time between each trace. So here we go, we have a distance, and we can check the attenuation. The attenuation can be from over here, and you follow the graduals, and we can see that the graduals are 5 dB per division, and so we're going about a half a dB, so we got a half a division, we're going about 2.5. We can do that with our cursors if we want to put the splice loss. And we can come over here and we can put the cursors on the different ones. And we can see what it reads down here, about 3.21. So you also have a coarse button here that allows you to fine tune it and be able to make it go closer. Again, I'm going back to the splice, the loss, and just showing you the coarseness and the full speed. So again, this is how this works. When you're satisfied with your trace, there's a button over here called copy. When you push the copy button, it produces a hard copy and it shows your trace on it. It comes out on a thermal printer. So you can keep that. It also has a disk, and we can put it on the disk, take it over to the computer in the lab, and thanks to Stan, we have an old floppy disk reader. Put it in the reader and you can print out a full page and show your trace and go through the software and manipulate it and see what your trace does. So the last thing you want to do is turn off the laser. The last thing you want to do is turn off the laser. Well, one way to turn it off is turn off this. So again, that's how this works. Hope you got to understand, and good luck.